Okay, in this video we're going to have a look at what's called the molar volume of gases. Hopefully you've watched the little introduction video, and this builds on that first video just to give us some examples of actually how to apply the equation. So the equation that I'm talking about is down here. So the volume and the moles of a gas are linked. So if we have the volume of gas, then the relationship is its moles of gas times by 24 decimeters cubed. And this is because we know the relationship of 1 mole of any gas, doesn't matter what that gas is, occupies a space of 24 decimeters cubed. So this equation can be turned into a triangle, as you can see here. And often I talk to my class about remembering that its volume is moles 24. So moles times 24 is equal to the volume. So what does this mean in some examples? Let's have a very quick look. So here the question says we've got 1 mole of helium. Helium's a gas, so it's going to follow this rule. So 1 mole of helium is a straightforward one because that is going to occupy 24 decimeters cubed. As is this one, this is still 1 mole, it's a different gas, but it's oxygen, and that's going to occupy 24 decimeters cubed. So it's straightforward. Here we've got a slight change in that we have got 2 moles. So I want to know the volume. I can go to my triangle. I can say the volume is moles times 24. The number of moles in this question is 2. Times it by 24. That gives me 48 units decimeters cubed of volume. Same here, slightly more difficult, but using the equation becomes straightforward. So the volume is going to be moles times 24. In this example, we have got 0.5 moles, times that by 24, and that gives me an answer of 12 decimeters cubed when we're using this relationship. We can expand this, and there's some here for you to have a go at yourself, and we can check the answers when you've done them. But you can expand this thinking to this situation where we use the volume of gases to link to the moles of gases. What this means, we just look at the moles first in this question. So here we have got, from the balanced equation, we have got 1 mole of methane, we have got 2 moles of oxygen, and I have got 1 mole of carbon dioxide. I'm not including water because water is a liquid, and this relationship is going to relate to gases. Look at the question. The question is asking us what volume of oxygen is needed to react with 40 centimeters cubed of methane, and what volume of carbon dioxide is going to be produced. So if I write down here that the start of this reaction we have got 40 centimeters cubed, and all I'm going to do is use the ratios, the stoichiometry between these chemicals in order to work out the ratio and the volume. For example, if I go from here to here, I am doubling the number of moles. Therefore, my volume would also have to double to follow that ratio. So that would mean I would end up with 80 centimeters cubed of the gas. If I go from here to here, my ratio is 1 to 1, so I'm timesing by 1 in effect. So if I go from here to here, the ratio is 1 to 1, times it by 1, and that's going to give me exactly the same volume of gas produced. So we can use the ratios, link into the number of moles in order to work out the volumes of gases involved. Again, there's a couple for you to practice and try yourself, and we'll go through the answers in class.